Hello, today I will be explaining when and how to use the chain rule. So the chain rule is used to find the derivative of a function that is comprised of one function inside of another. For example, if we have the function y, which is comprised of the function g of x inside of the function f of x, well, to find the derivative, we can simply find the derivative of f of x, which is the outer function, and we can leave g of x untouched inside, and we can multiply that by the derivative of the inner function, g of x. For example, if we have the function 3x plus 2 all to the power of 4, we can identify our inner function being 3x plus 2, and our outer function being x to the power of 4. To find the derivative, we take the derivative of the outer function, and we keep the inner function the same. So we would move the 4 into the coefficient and subtract 1 from the exponents, and we would leave the inner function untouched. And we would multiply this by the derivative of the inner function, 3x plus 2, and the derivative of this is just 3. And therefore, we get our final derivative of 4 times 3x plus 2 to the power of 3 times 3, which gives us 12 times 3x plus 2 all to the power of 3. One common use case that we should be able to identify is in the case of square roots. So let's say we have the function g of x, which is the square root of x plus 2. Well, we can see that this is the chain rule can be applied here because we have an inner function, x plus 2, and the outer function, the square root of x. So to find the derivative of this, we can simply turn it into the same format that we saw earlier. And this is because if we have the square root of something, it is equivalent to that thing to the exponent of 1 over 2. So the square root of x plus 2 becomes x plus 2 all to the power of 1 over 2. And we can follow this logic for other roots, such as the cube root, the fourth root, or the fifth root, and so on. And we would set these exponents to 1 over 3, 1 over 4, and 1 over 5.